Most people today use computers for personal as well as business use. As powerful as computers are, however, they do have their limitations. Most notably, their lack of ability to reason as humans do. The human brain processes information through neural activity that takes place within and between specialized brain cells called neurons. The brain is comprised of billions of these neurons, which communicate with each other through electrical impulses. This process allows humans to perceive and make sense out of repetitive patterns and learn from their past experiences. Computer scientists in the field of artificial intelligence have spent decades developing various mathematical computer models of the human brain, known as neural networks. Neural networks can be utilized to process large amounts of financial market data involving literally hundreds or thousands of global markets. Neural networks can then find hidden patterns and nonlinear relationships within that data. This capability allows neural networks to make accurate forecasts of future market behavior based on these repetitive patterns. Using sophisticated mathematical algorithms, neural networks implement an iterative learning process in which connection weights and transfer functions between layers of neurons allow the neural networks to work their magic. One such algorithm that's been applied very successfully in financial market analysis is known as backpropagation. Starting with random weights, the results of early learning iterations have relatively large errors. As the learning process is repeated over and over again, thousands of times, the connection weights get adjusted, resulting in smaller and smaller errors until the iteration with the smallest errors is found. Through this repetitive process, neural networks forecast what is likely to happen in the markets in the near future with relatively high degree of predictive accuracy. This gives their users a decided advantage over other traders who still rely on simplistic approaches to technical analysis, such as lagging technical indicators, which offer little to no predictive value. Following the globalization of the world economy and the interconnectedness of the world's financial markets in recent years, today's traders understand that global markets no longer trade in isolation of one another, and therefore shouldn't be studied in isolation. It's not good enough to think that the price of gold is the only influence on the price of silver, or the price of oil solely influences the stock market, or that the price of one tech stock is the only influence of another tech stock. The fact is, each market is influenced by many other markets. Traders need to know not only which specific markets have the most influence on the market they're trading, but also how much each related market affects the market they're trading. Sure, you can eyeball charts, look at spreads between markets, or calculate linear correlations between any two markets to get a sense of their relationship to one another. But with these approaches, you can't even begin to grasp the complete picture of how all of these markets are dynamically affecting each other, and more importantly, how they're affecting the market or markets that you're trading. Luckily, this is a perfect application for neural networks. They are great at determining which specific markets have the most pronounced impact on any target market. Then, neural networks can make highly accurate, short-term predictions of the target market. Even more importantly, neural networks can be used to create powerful predictive technical indicators that transform commonplace, widely used indicators into predictive indicators that actually lead rather than lag the market. With these capabilities at their fingertips, traders gain insight into future market dynamics before other traders even suspect what's going on. This is the competitive advantage that neural networks applied to global intermarket analysis can give you.